Hello dear students, welcome back. This is Krishna Chaitanya Nagaraju, Assistant Professor, Department of CSC, GRIT Hyderabad, your course instructor for Artificial Intelligence course. We were discussing the Knowledge and Reasoning Unit 2, from which a topic Knowledge Based Agents Introduction, and this is the second part of the introduction in continuation with the previous video what you have seen. These were the learning objectives and learning outcomes that we wanted to cover. So let me just in a nutshell revise what we studied. What is the knowledge? Awareness or familiarity gained by experience of a fact or situation. And an expert system consists of all these components where our concentration is majorly on the knowledge base. How to create a knowledge base? A agent which has got the knowledge base. How the knowledge can be represented. So that's what our major aim for this unit. So we wish to create an agent that is not just reflexive but to have an internal state of knowledge, update its knowledge based on observations it makes, apply some reasoning on that knowledge and then take an action. So in simple, the solution what we are looking at is a knowledge based agent. So the knowledge bases, when we consider the knowledge bases, we have a knowledge base upon which we will be having an inference engine. The knowledge base is domain specific content. The for the example, take the chess game. The rules will be pertaining to the chess. When you develop a knowledge base for medical facility, that will be pertaining to that particular anatomy of the body or the human being. And inference engine is domain independent algorithms to deduce the knowledge from the knowledge base. So what it is, there is knowledge base is set of sentences in a formal language, and we can have the way of building this knowledge base can be declarative, like to building an agent or other system, we need to tell it what it needs to know. So this tell is an important thing here, and then it can ask itself what to do. Answers should follow from the knowledge base. So tell and ask, two operations. Agents can be viewed at the knowledge level, that is what they know, regardless of how implemented. At the implementation level, if we speak, the data structures of the knowledge base and algorithms that manipulate them need to be understood. So when it comes for the architecture of a knowledge based agent, it can be viewed in three ways. One, at knowledge level. Take an example of a taxi driver agent, who knows that Golden Gate Bridge connects San Francisco with the Marin County. Now this is simple information at a known level, that is knowledge level, the most abstract level. Describe agent by saying what it knows. Now when it comes for the logical level, connection we need to understand the level at which the knowledge is enclosed into sentences. The knowledge now to be represented in the form of some sentences. So example like this: links Golden Gate Bridge, San Francisco and Marin County. So this is how I can represent at logical level. Now when it comes for the implementation level, the same sentence need to be encoded using some programming language like Lisp or Prolog. So at implementation level, the physical representation of the sentences in the logical level need to be considered. For example, like this: the same information of a taxi agent knowing that the Golden Gate Bridge connects San Francisco with the Marin County can be represented like this, right? So the features of knowledge base or knowledge representation is generally a substitute. The knowledge representation is nothing but a substitute for the thing itself, which is used to enable an entity to determine consequences by thinking rather than acting. Think about the consequences. Now it is a set of ontological commitments. The knowledge representation is a set of ontological commitments, that is an answer to the question, in what terms should I think about the world? Knowledge representation and other fields of study, we need to look at logic that provides the formal structure and rules of inferences. And ontology defines the kinds of things that exist in the application domain. And then we have computation, supports the applications that distinguish knowledge representation from pure philosophy. Our concentration would be at logic, how to implement the logic and represent the logic. So the requirements for any knowledge based representation is, any language if I am using, is representational adequacy. It should allow to represent the knowledge we need. And inferential adequacy, it should have the ability to infer new knowledge from a basic set of facts. And then in inferential efficiency, how efficiently it is inferring. And then clear syntax and semantics, that one we are making use to represent this, what the allowable expressions are and what do they mean. It should be very clear, and it should be very natural and easy to use. That's what we call it as naturalness. Now the basic environment, knowledge based environment, the central component of a knowledge based agent is its knowledge base. Everything is around the knowledge base. If I am speaking based on the knowledge I am having. So all my discussion is based on the knowledge base what I am having about artificial intelligence. So that is, knowledge base is the crux. There must be a way to add new sentences to the knowledge base and a way to query what is known. So there should be some mechanism like what we discussed in the earlier slide, tell and ask. So the standard names of these tasks are tell and ask respectively. Both tasks may involve inference, that is deriving new sentences from old. A tell may make it to derive new sentence. In the same way, ask may make it to derive new sentence. A simple knowledge based agent, let us try to, can you imagine what could be the function of a simple knowledge based agent? It should return some action, and these two things should be there, tell and ask. Telling based on some percept at a given time, and then ask query based on the ask, again it may gain more knowledge, so one more tell. That means all probably I'll be having one tell, one ask, another tell, and a specific time t, an action to perform a. So let us see with this idea. Now as what we have discussed, if you look at the function KB agent receives a percept and returns an action. Now knowledge base is static because it based on the actions it goes on improving. Once we allocate the knowledge, it goes on improving the knowledge base, and time is what changes. So t is a counter, initially 0 indicating time. Now tell KB make percept sentence based on the percept and the time. So this is making the percept sentence and telling the knowledge base this is what it is. So you are giving knowledge to the knowledge base. And ask knowledge base make action query at a particular time. What action need to be performed? You have to make this action query on the knowledge base and ask it. This knowledge base has to return an action. Based on this action, once again you can incorporate more knowledge. So based on the action at a time, I can make action sentence. This is the action what I have performed for so and so input. So that is a new knowledge what I am gaining probably. So that adds up to the knowledge base. So tell and goes to the next time. T is next instance of time. So t tends to t plus 1 and return the action what it need to perform. So this is your simple knowledge based agent. I hope this is clear for you. So the agent must be able to represent the states, actions, etc., incorporate new percepts, update internal representations of the world, deduce hidden properties of the world, and deduce appropriate actions. This the agent should be able to do. So the details of the representation language are hidden inside 3 functions that implement the interface between the sensors and actuators and the core representation and reasoning system. The details are abstract. Make percept sentence, one we have already seen, right? These things we have already seen. Make percept sentence constructs a sentence asserting that the agent perceived the given percept at the given time. Make action query constructs a sentence that asks what action should be done at the current time. So this is another function. Finally, make action sentence constructs a sentence asserting that the chosen action was executed. So what are the three functions? Make percept sentence, make action query, make action sentence. Take a look at this once again. Make percept sentence, make action query, make action sentence. Three functions. So the details of the inference mechanism are hidden inside tell and ask. Those are the two more things. One can build a knowledge based agent simply by telling it what it needs to know. The agent's initial program before it starts to receive percepts is built by adding one by one the sentences that represent the designer's knowledge of the environment. Imagine when you are born, when you are growing up, your mother tells you some information. This is milk, this is water, this is hot, this is cold. That is out of the knowledge what she has got. So she is designing your brain, the initial program. Like mother is the first guru, right? So in addition to telling it what it needs to know, we can provide a knowledge based agent with mechanisms that allow it to learn for itself. Now generally intuitively we learn from our environment, so the same way we can also provide. This is very important. On by its own it is learning and adding, extending its knowledge base. That means it is becoming autonomous. The agent can be fully autonomous. So we will see the remaining things in the next session. Please, once again I want you to go through this particular thing. Thank you for listening.